Okay, welcome back to day 2 of the 3ds Max SDK training. My name is Kevin Vandekar, and I'm going to take you through today the basics of the SDK. We're going to talk about some terminology and just some of the fundamental aspects of how to get your plugin to load and how it connects to 3ds Max. So before we get started with the lesson, I'd like to switch over and just cover review the exercise from yesterday. So the first thing you should have done is been able to locate the online documentation. So just by installing the SDK, there is a help directory, and within that help directory is the SDK documentation link. So that takes you to this page at the Autodesk.com site. And on this page you'll see all of the media and entertainment product documentation for the SDKs. Okay? So you'll see MaxScript, Japanese MaxScript, and the 2013 C++ SDK. Also note that the other products are located here as well. You have FBX, Maya, Motion Builder, Mudbox, and Softimage. So simply clicking the online link will take you to the documentation, and here you'll have the programmer's guide, and this is where many of the things we talked about yesterday and ongoing throughout this training are documented. Okay, so hopefully you were able to find that. If not, let me know. The next thing in the exercise was to set up your compiler to use the plugin wizard. So in 2013 SDK, out of the box, or basically, the version you get from us, the wizard is not working properly. So I've recently updated this myself, and I gave you the package yesterday, and hopefully you were able to install that. So again, please let me know if you had any troubles with that. But basically, once it's installed, you should be able to go to File, New, Project, and you'll see the plugin wizard listed. Now, I've versioned it as well, so I could have 2012 and 2013 installed side by side. I'm going to create a new project here and just say OK, and that starts the wizard. So the assignment was to create a utility plugin. So that's at the bottom of this list. You click Next, and you're going to get the plugin class name. Now this is also what you've probably already found, is that this is also the project name. So it's going to be named that. All the the project files, the binary itself is going to be named whatever you put here. Depending on which class or which type of plugin that you want to start with, there could be more than one class here. Because we chose utility, there's only one. And then you need to assign a plugin category. So I'm just going to say ADN samples, and then the plugin description as well as ADN samples. Now these are not terribly important, but these will show in different parts of user interface. So you should put something meaningful into these areas. And then the last page was to set up the locations to your SDK as well as to your installations of the 3ds Max product itself. So if you read through the documentation, the exercise documentation, basically, I suggested using the environment variables. Now these environment variables are set simply by installing the SDK. So here you can see I've got two different versions, a 2012 and a 2013 version of the product and the SDKs installed. So for this class you'll be interested in ADSK 3ds Max SDK 2013. And then your specific product version. So there could be either an x64 version of that or a Win32 version. And you'll notice that between 2012 and 2013 they changed the designation. So 2012 it was x32, and 2013 it's x86. I'm not sure why they did that, but it is what it is. Now, if you also happen to be working with 3ds Max design instead of the entertainment version of 3ds Max, you'll see that even it has a different version of the environment variables. So you can basically target all versions of 3ds Max, regardless of the year release, and as well as the design versus entertainment version. So in this case, I have Max Design X64 2013 installed. Alright, so plug those variables in as appropriate, and what that's going to do is that's going to transfer those variables into your projects, and then that's going to make it a little bit easier when you move forward into new versions to port your project files themselves. So you just change the variable, and that's going to update the project settings. So I'll click Finish, and what you should have as a result is a skeleton file with a DLL entry file. We're going to talk about that today. You also should have a source file that contains the derivation from the utility object. Okay. Now you'll notice that in many cases, the way the project wizard works is it puts the class definition itself in the CPP file. So this is just a style. It's the way 3ds Max engineering likes to work. So the header file itself doesn't contain a whole lot other than includes. Okay, so most of the definitions and the implementation is in the CPP file. You can feel free to separate that however you want, but for the purposes of this class, we're going to use the wizard style, and this is how it's structured. Okay? So, following all these steps, you should have gotten to a point where you could actually build the utility object and work with it. So, reviewing the structure of the plugin project, this talks about the properties of the settings themselves. So if we go over here and we say properties, you're going to see that those environment variables that we specified in the wizard are now transferred into the properties of the project. Now, I also mentioned that the debug Unicode settings are not the ideal ones to use. So the reason for this is that under the C++ settings, under code generation, you're going to see that these are true debug targets. Now, as is typical when working with a release product such as 3ds Max or AutoCAD or any other product that you're working with and you're adding support for through an add-in or a plug-in, you're usually working with our release versions. So you cannot use the runtime library from the debug settings. Okay, so this is why 3ds Max provides this thing called the hybrid settings. So you go here and you look at the runtime library and you'll see it's actually using the release runtime. However, when you go to things like debugging, you'll see that generate debug information is turned on. Code generation, has exceptions and different things that relating to debugging turned on. So this is the one you want to use for debug, and then there is also a release version. So hybrid Unicode is the one we're going to be using throughout this class as the settings to support. Now you'll also notice that there's a Win32 and an x64 platform. So depending on whether you have the x64 version, which is now the most common version, or the Win32 version, you need to switch the platform. Otherwise it's going to build to the wrong location. So the other thing you're going to notice is that under Win32, for example, you can go to General, and the program database is set to Z lowercase I. Now, we do support edit and continue on Win32. So this is one reason, and I mentioned this yesterday, that you might want to use the x86 version of 3ds Max simply because you can turn on edit and continue. If you set this to x64 and you try and change this value, when you build, it's going to complain, and it's basically because Microsoft does not support edit and continue for Visual C++ on the x64 platform. Okay, so just know that that is a limitation. So it's one good reason to use the Win32 platform. All right. And the last thing we really wanted you to do here was to add these prompts to the 3ds Max project, begin edit params and end edit params. All this would do is when you're actually running the project, it's going to show hello 3ds Max in the context of when the utility object is initiated, and it's going to pop that prompt away from the prompt area when the context is exited. Okay, and we're going to talk about that a little bit more today. All right. So one of the things that I mentioned here in red was to make sure that if you're using some of the samples that's provided in the SDK and you're building them to the 3ds Max production directories, make sure you back up and rename any existing binary files first. Okay, it's very important because as you're testing and changing things, you might mess up some of the built-in behavior of Max. And so although it's very convenient and nice to have the source code, it can also be confusing and cause you problems in your development environment if you rebuild, let's say the melt modifier, and you've changed something and it no longer works and you're in a production deadline. Okay? Alright, so let's get started with Module 2. This section is going to talk about the basics of the SDK. The goal here is to cover the DLL structure, which is really the basics of how you get a binary to load into 3ds Max. We're going to also define some terminology that's used throughout the SDK, some basic things. And then we'll talk about what a plugin really means. What does that terminology mean? And then we'll go into how 3ds Max handles transformations of geometry. So first of all, a 3ds Max plugin is a Windows Dynamic Link Library, a DLL. It has a DLL main, and that's what 3ds Max itself looks for when it's trying to load. And then the DLL itself has to be located in a specific location. So 3ds Max has several different ways of configuring that, but the main location will be the plugins directory. Okay, 3ds Max also has an STD plugins directory, which is standard plugins, and those are where all of the in-the-box plugins reside. You'll see that many of the samples that we provide in the SDK actually build to that STD plugins directory. But for your third party, your not-in-the-box plugin, the ideal location is the plugins directory. So in order to load into 3ds Max, you also have to export certain functions. So first of all, we have a few functions that define the classes within the plugin itself. So you can have more than one class. So this is what the lib number of classes defines. And then for each class, you have to provide a class description. And then you also need to provide a description of the library, a version, and then optionally you can also implement initialize and shutdown. Now these are global functions to the plugin itself. They're not class specific. So when your DLL is initialized, the lib initialize is called, and when 3ds Max is shutting down and your DLL is unloading, that's what shutdown is for. So those are very primitive functions. They are useful for certain things, but don't rely on them for class-specific details. And then the final one is can auto defer. And this is also optional, but in 2012, the behavior of can auto defer changed. So it may be required now depending on what functionality you have. So can auto defer has to do with when your plugin is loaded, can it be deferred until later use? If it needs to be loaded all the time, then you should return false from this to make sure it's loaded and kept in memory. If you don't implement this or you return true, then basically 3ds Max is going to say, okay, I can defer that until it's really needed. Okay, so it's a memory consumption issue. It's performance. So in addition to implementing these functions, you also must export those functions somehow. So the typical way is using a def file, and this is something that the wizard creates. Many of the samples provide the def file. Something that's a little bit more modern is you can use the pragma comment. So either way is fine. You're going to see us use the def file throughout the class, and that's actually one of the more obvious ways, because the presence of a def file basically means that, you're publicly exporting certain functions, and that makes it obvious. So let's take a look at some code for the DLL entry. So first of all, when you use the wizard, it's going to almost always create this DLL entry.cpp source file. And within that is your DLL main. And you're going to see this DLL main looks a lot like any other DLL main would. It's a standard Windows thing. And this is what initializes the DLL to start with. Now you could have some additional things here if you needed it, but this is the basics. The lib description is going to return a string, and almost always this should be like a resource ID. This is going to help you in the context of globalization if you need to convert it to other languages. The number of classes, and in this case we're returning 1, but it may be more than 1. The number of classes is then whatever value this returns is passed into the lib class description function, and it's going to switch on it's going to basically call this function so many times depending on how many classes you have, and for each one it's going to pass in the index, and you're going to switch based on the class that you want to register. So for example, if you have 3 classes, you would return 3 up here, and then it's going to this function will be called 3 times with 0, 1, and 2, and you would switch. For case 0, you would call the class descriptor for the first class. If this is 1, for the second class. If this is 2, for the third class. Okay, so this is how the classes actually get identified to 3ds Max. The lib version almost always is going to be this #define. Okay, this is version 3ds Max, and this basically is used to identify yourself as working with a current version of Max or a compatible version of Max. Okay. Lib initialize, again, remember these were optional, so you don't even need to export these, but if you do, you could do some initialization, and then the alternate is the lib shutdown. And then finally the can auto defer. So in this particular example, we are returning false, telling 3ds Max that you cannot auto defer us. We need to be in memory from beginning of 3ds Max to the end of 3ds Max. Okay, so this is changed from 3ds Max 2011. So basically the behavior has been made the opposite. So you need to make sure you implement this if you expect to remain in memory. Okay, just implementing these functions is not enough. You can see that we use the DLL export to export them from the module, but we also need to use something like a definition file to make sure that these are exported without name mangling from C++. So you can see here I have a def file and I have each one of these functions exported. Okay, so the def file is the most common way to do this. Just note that you can also use the pragma comment style if you want to actually put it into your CPP source code. So either way, they do need to be exported. Some additional basics are the class descriptors, and in the current context you would derive from class descriptor 2. So these are versioned. There is an older one, and some of the samples do use the older one, but for anything new you should derive from class descriptor 2. And then there's also the notion of a class ID. Now this class ID uniquely identifies your plugin to 3ds Max, and this is the fundamental system to make your plugin unique. So this is very important to make sure you create a new class ID for any new plugin that you're creating. Okay, so there's a class ID macro that you would use to identify your new class, and then we provide a tool called GenCID to create a new class ID, which is guaranteed to be unique. So first of all, let's take a look at the code for this. So the class ID here, you can see it's a pound define, and I'm calling it exercise 01 class ID, and this is actually something generated by the wizard. And then we use the macro class ID, and 2 hexadecimal values are passed in. Okay. Now these hexadecimal values are generated by a tool called GenCID. This is a tool that's provided within the SDK. So let's take a look at where that's located. If you go into your SDK directory, into the help directory, you'll see GenCID resides in that help directory. Okay. When you run it, it will automatically generate a new one. You can copy to the clipboard, and you can see that the syntax here is already implementing the macro. Okay, so you basically copy this to whatever definition you want to assign it to. So you can generate new ones, and there are also ways to run it to generate multiple ones if you need to. So the class ID uniquely identifies the plugin itself, and then the class descriptor defines the rest of the information that 3ds Max needs to use. So once you've assigned your class ID, so in this case exercise 01 class ID, you're going to use that in the class descriptor to tell 3ds Max the other information about your class and how it relates to 3ds Max and its subsystems. So in this case, I'm deriving from class descriptor 2, and I'm implementing isPublic. That's a default thing for true. I'm implementing the create method, which is returning an instance of my class. We're returning a string to identify the class name. We need to return the superclass ID. So this is the superclass ID. Basically, it's the class ID of what you're deriving from. So you saw we are deriving from utility object. So superclass ID is going to be utility class ID. All right. And then more specifically, what is our class ID to uniquely identify us within the system? And here's where you see the exercise 01 class ID. So this is what is defined up here by the macro. Okay. We also provide a category, And you'll notice in the case of both category and the class name, these are resource strings, but they could be hard-coded strings as well. We also have an internal name, and we return also the H instance. So this is returning, as you can see here, the owning module handle. Okay, so let's talk about some terminology now. This is just kind of a quick overview of some of the different terms that are used throughout the SDK, and the idea here is to kind of familiarize you with the terminology as well as make sure you don't confuse some of the terminology with the more common meanings. So the first thing we're going to look at is plugins. So, the documentation has a description of this, which is a plugin describes scene entities such as procedural parametric objects, materials, processes that manipulate them, such as the process of rendering or exporting a scene, or customize how 3ds Max looks and behaves. Plugins can be written in C++, MaxScript, or .NET. Primarily, though, you have to remember it's C++. There are plugin terminologies used in MaxScript or .NET, but right now the full plugin concept is C++ only. So again, most plugins are written in C++. So a plugin basically handles any task in 3ds Max that you can think of. So even many of the features that 3ds Max has are written as plugins. So you remember we talked about the sample code and the SDK. Many of those plugin samples are actually features within 3ds Max. So most plugins will fall into one of the following categories. So there's a whole list of things here. The one thing that you should know is that the file extension determines the type of plugin in terms of its life on disk. It does not define the class itself. So a plugin of multiple types can live in, let's say, a GUP, which is a global utility, or a standard utility object. Okay, so the file on disk determines load order, but it also typically identifies the type of plugin it is. So the core interface is something that is the root of the application. It's a singleton you're going to call get core interface, and it's going to give you a interface to access the application. So you'll have access to things like the viewports, the scene graph, the ability to create objects, app level commands. So for example, you can do things like save and initiate the renderer. There's some user interface access, so the built-in user interface in particular is available from the core interface. And also things like the application state. What state is it currently in? You can call from the core interface. So this core interface is versioned, and what that means is that anytime we add additional functionality, it gets a new version of the core interface, and that just simply makes it easier to maintain backwards compatibility with older code. So to take a quick look at all the different types and their base classes, here's a list. Okay, this is pretty complete, I think, as of today, but you can see that there's a large number of base classes. And this is all documented in the documentation, so I'm not going to read through this. So some terminology within the SDK itself. We want to clarify that typically when we refer to an object, it's not necessarily a class in C++ terms. So an object is not necessarily an instance of any generic class. Really what it is something derived from the 3ds Max version of a class called base object. Okay? And this often refers to a geometric object or a modifier. Another term that's sometimes confused is that we commonly say we refer to references, which is basically a relationship between instances of objects. So a reference means, okay, this is a parent and it has a reference to its child, for example. Okay, it's not usually the typical C++ reference. And then finally, instance is an instance of a C++ plugin class. So, and this is unrelated to the 3ds Max instance feature. So in 3ds Max you can take an object and instance it. But in the SDK we're referring to the more typical instance of a C++ class. Alright, so let's take a quick look at the high-level class hierarchy. So at the very top you'll see that there is a class called Animatable. And this is the root class of almost everything within 3ds Max. And what that gives you a clue about is that, well, pretty much everything is animatable. So that's a good thing. Derived from animatable is the reference system. So at the top level we have what's called a reference maker, and then we have a reference target. And these are the classes that define the relationships between objects and how they're structured. We'll talk about that in detail later. So these are really the base classes that make up the system, and then under that you can see we split off and we have the base object. And remember I mentioned that modifier and object are derived from that. And then under object you have the more specific objects like geometry, cameras, lights, and helpers. On the other side of the branch we have things like the materials. So here you can see those main classes. Also controls, so animation controllers, the renderer, different things like special effects, so the atmospheric and base shaders. And then off to the side, which are not part of the hierarchy directly, are things like the utility object, the global utility, scene import and export. Alright? So this leads us into the first real concrete object that we're going to talk about, the scene. So the scene obviously is what you see in the editor, what is contained within the Max file format, and what basically contains all of the objects. So it consists of a graph or a tree organization of nodes. Nodes essentially wrap the objects in the scene. So every object within the scene has to have a node in order for it to live within the scene. Objects that can be assigned a node in the scene will derive from the object class. So ultimately, no matter what level they are in the hierarchy, they're going to ultimately derive from object. So here's some examples: geometric objects, lights, cameras, the particle system, world, space modifiers. Okay. So those, because with the modifiers, because they're world space, they have to live in the scene level, whereas a regular modifier might be attached to an object. All right. So it is the container for plugins and the associated data. So if you have a geometric object plugin, the container that's going to hold that instance of any of those objects that are created is going to be the scene. And the scene itself is implemented by the system. So it's not something that you can derive from and make a custom scene, for example. The scene is a very basic object that needs to be owned by Max. So a node is the wrapper. So every object in the scene must be assigned a node. And again, the node is something implemented by the system. So 3ds Max tools can display nodes such as the Scene Explorer, the Track View, and the Schematic View, and of course the editor itself. So a node's functionality includes the pointer to a scene object. Okay, so the node itself knows that it belongs to a scene. The information about modifiers applied to an object. So if you have a sphere, like in our MaxScript example, that has the noise modifier attached to it, the node knows about that. Geometry information, so for example the transform, this includes position, rotation, and scale information. It stores information about the material that defines the surface properties. So the node holds the material. It's not the object itself, but the node. It also manages the appearance and surface properties through the material, storing the node hierarchy information. So if the node isn't part of the root of the scene, it might be part of another parent node. Okay, so there's this parent-child relationship that can happen at the node level. So for example, particles belong to a particle system. And then there's sub-animatables. Okay, so you would access the node itself through an interface class that's called iNode. So that leads us to just a quick discussion about the reference system. So the reference is a dependency between either two plugins or a 3ds Max object and a plugin. And that's a very basic way of forming it. But we can have, like in the previous slide, an example of a particle system owning the particle nodes within it. Okay. So the reference system is used for many purposes, including notifying the dependent scene objects of changes or events. It also manages automatic deletion of objects, and also handles the loading and saving of the scene graph. So a node that's assigned to a scene is going to be saved because there's a reference from the node to the scene itself. So these relationships can be viewed using the schematic view. So some references are actually not shown, but most references are. So an example of things not shown would be like parameter blocks. And we'll talk about those in a second. So here's a quick diagram of how the reference system works. So there's two types of base references. There's the reference makers and the reference targets. Okay? And you'll see, for example, the camera is a reference maker, and it has a reference to the parameter block, but it also has a reference to a look-at controller. Okay? So the blue lines represent a reference link, and the red lines represent the direction of reference message propagation. Okay, so in this case of the camera, the look-at controller also has a parameter block, and let's say that parameter block has a reference to another object that is a teapot. Okay, and then for whatever reason that teapot changes. Well, there can be a message that's passed back, and it will go all the way back to the camera and any parents of the camera. Okay, so it's all about ownership as well as messaging in terms of how things are referenced. So that leads us to talking about plugin data, which is primarily done through parameter blocks. So parameter blocks are basically containers that hold data about a specific object. So if you implement an object plugin, and that object is a sphere, and you need to store the radius of that sphere, well, the parameter block is going to store that data. Okay, and the parameter block can be any size. It can contain all the data that you want. And this is represented by the interface class called iParamBlock2. And these are always reference targets. So a parameter block is always owned by some sort of object. So 3ds Max uses these parameter blocks to expose UI elements to the user. So this can be automatic or manual. So many of the plugins that you're going to see in the samples, the rollout panels on the right hand side are implemented through parameter blocks. Okay, and there's a whole system that allows you to define how the parameters are stored, as well as what kind of UI element is representing that parameter. Okay, so it's a very convenient way to not only store the data but provide a UI element with it. It also is used to notify the plugin of changes to parameters using the reference system. So we looked at that with that graph. It's also used to serialize the plugin data. So anytime the file is loaded or saved, the parameter block system is reading and writing that data. Okay. And finally, it will automatically expose plugin data to MaxScript. So when you saw the MaxScript that we were showing as an example yesterday, a lot of that data is actually published to MaxScript through parameter blocks. So you don't actually have to implement the sophisticated aspect of function publishing to get access to the data. The parameter block will kind of do that for you automatically. And then finally, I'd like to talk about animation time and controllers. So the base class for nearly everything is animatable, and this gives you the base parent-child relationships using the reference system. The track view is a visual representation of that concept. Okay, so anything that's an animatable can come into the track view. When we start talking about time, this has to do with intervals, and within 3ds Max this is called a tick, and a tick within 3ds Max is 1/4800th of a second. Okay, so that's the really low level time unit. So a time value then represents how many ticks you would have in, let's say, an interval. And then finally, controllers. So controllers is a specific plugin type that's responsible for directing all the animation. So they're all derived from the control class, and they are either keyframe or procedural type. Okay, so you have to decide that up front. So within that, there's 6 basic types of controllers. There's the floating point controller, the point controllers, which is represented by the 3ds Max type point 3, the position controllers, which is a matrix 3, rotation controllers, which is a quaternion, scale controllers, which is a scale value, or transform controllers, which is also a matrix 3. So if we take a look at the class hierarchy to see where this resides, you'll see animatable again at the top, and everything under animatable can be animated, but the controls right here highlighted, these are the things that direct the animation. Okay, it uses time and the fact that the base class is an animatable in order to control the ultimate animation. Okay, so now let's talk about the creation of scene objects. So we've looked at some of the basics as to how the SDK works, and we talked about both the superclass ID and the class ID. So first of all, to create an object, you're going to go to the core interface, and there's a method called create instance. Okay. Now every type of object, has these class IDs, so you need to first specify the superclass ID and then the class ID that's unique for the plugin class. So you're going to find many of those superclass ID declarations that that you would need to create any of the objects described in the documentation, and if you want to look in the header, it's directly in plugapi.h. So for example, to create a cone, we're going to call get core interface, create instance, and we want the superclass ID geom object class ID, and then we need to create a class ID for the cone class ID. Okay? So some of the legacy objects, the objects that have been around longest, they only have the what we call the A portion of the class ID defined, and so in those cases the B portion of the class ID are 0. But for all new classes there's going to be an A and a B portion, and you saw that format with how the gen class ID tool created it. So this create instance returns a void pointer, and so that's just to make it easy to return any type of object. But because the class IDs are so specific, you can safely cast directly to those known objects, and you can cast to any level. So for example, in the case of a cone, because it derives from geom object and ultimately from object, you can cast to any one of those levels within the hierarchy depending on what you need access to. So simply creating the object in memory is not enough. So it needs to belong to the scene in order for it to be visible in the model. So we now use another method to create the object in the scene. So the inode is what will allow the scene to show the object, and the inode contains the transform and position data and other data about the object as well. So the relationships between the nodes in the tree are called parent-child relationships. Each node's transform is relative to its parent. So when you have multiple children of a parent and multiple parent-child relationships under a parent, you can see that the transformation chain will adversely affect the node. So you definitely need to understand that the parent's transform, the child's transform, its children's transform are all going to be additive. Okay? The tree is basically rooted in the invisible root node. Okay, so there's a root node that basically contains everything within the scene. So to create a new node, you're going to go back to the core interface and you're going to call create object node, and you're going to pass in something of type base object. So pretty much anything you create that's going to be scene oriented especially is going to be derived from base object. So this returns you the new inode, and so now you have the node that you can work with. So it now exists in the scene, but it's going to have defaults like the origin is equal to 0, 0, 0, and it's going to get a default name assigned to it. So at this point, you would then go ahead and modify the inode for richer functionality. So on the inode, there's some primitive data stored. So for example, the wire color, so basically the wireframe color, the name of the node, the visibility, other things such as box mode, that's just how it's displaying, whether it casts shadows, back culling, and there's many others. And then, of course, one of the more important aspects of the node's responsibility is to position the object in the scene. So the node itself has a transform, and this is a matrix 3, and you would call set node TM, which is transformation matrix, and notice that it's taking a time value. So this is where you can start to understand that the transform can be animated, and then of course you pass in the matrix itself. So there's some examples. You can go to the matrix itself and you can set a translate matrix, you can set rotation matrix, and scale matrices. So there's basically different methods that are given here as an example that will allow you to transform the node to the position you want. So let's take a quick look at the code to do this work. So what I'm going to do is I'm going to switch over here to Visual Studio. And first thing I want to show is a little bit of background because we haven't really talked about it yet, and once you start working with this next exercise you're going to need to understand it. So the way the user interface works is using Windows resource files. Okay, so what I've done is I've got two examples here, and I've added two buttons to make that possible. If I go over to the sample code, you can see the button 1 is going to call my exercise 2 classes get instance, which is a static, and then I can call the create scene object function. Okay, so this is all done in a callback that is typically called the dialog process. Okay, and this is how you hook into the 3ds Max user interface, and in this case it's a utility object, so it's going to show up on the panel. So if we switch over here to Max, you can see there's my panel that was created by this plugin. Alright, so let's just go ahead and add a scene object. So it's going to hit the breakpoint here for create scene. I'm going to step into this. So I step into it, and there's my get instance, and then here's the create scene object. So the first thing is my interface pointer. So you can see here I get a fresh interface pointer from get core interface, and that's where we're going to have access to the app. Now in this case I'm creating a box. Okay, so the object type is GenBoxObject, and you can see here I'm casting to that. And again, I can safely do that because this class ID positively identifies the object we're creating as this. Now typically this example doesn't have any error checking, so typically you want to check to see if this was actually created after the call was made, just to be safe. So use your typical C++ error checking to make sure things are working. Okay, so now I have the GenBox. Now what I'm going to do is on the box I'm going to set some values. So if you know how the GenBox works typically within the UI, it has a width, height, and depth, and it also allows you to set the number of segments for each of the width, height, and length values. Alright, so once I have all those set up, I can go to the GenBox and then I call the set params. And this could be different per object type. So you really just have to look into the SDK docs, into the SDK itself to see what things you can set. So in this case, they're all passed into a single function, and this gives my object its characteristics. So it's basically its size and how the faces are made up. Okay? So now I have that object in memory and it's got some size, but I also want to add it to the scene. So here's where I call the create object node with my GenBox, and that's going to return me a new node. Okay, so now that I have node, you can see that I'm going to use some of the properties of the node, like setting its name, to set up the name in the scene. Okay, so there is a function here that's called make name unique, and you should probably get in the habit of making unique names if you're positively naming your nodes, just to make sure there's no conflict. So this ensures that. If you don't assign a name, it's going to get a name automatically in the scene. And then we can set some other properties about it. So I'm going to set the RGB value of the wireframe to blue. And now I'm going to position it within the scene. So here you can see I'm setting up a transformation matrix, and I'm setting the translate to the point 10, 10. Okay, so this is a very simple matrix. I can create the I've created the matrix, I've translated it by the point, and then I set the node's transform with that matrix. And when I say set time value of 0, that's basically forever. Okay. And then there's also a separate transformation of the object itself from the node. So in this case I'm just going to do an example of setting the object's offset position to another 10 by 10 offset. Okay, so let's just finish running that, and you'll see the box gets created here. And let me switch to this viewport, and I want to just select it. And here you can see the object's pivot point is here. And it is 10 units from the origin. Okay, so this is 10 units. And then when I set the object's position, the offset position, I offset it 10 units more. Okay, so you can see its center is 10 units now off of its pivot point. So what this does is the pivot point now, if you do something like rotate, is here, and the object's offset gives you some interesting behaviors. Okay, so it gives you a lot of control, and this is why it's really, really important to understand all of the different ways you can transform things. Okay, so that brings us to the end of today's presentation, and we're going to talk about the exercise for you to work on. So you're going to find this document here, exercise 02. And so what we're going to do is we're going to start off like we did yesterday by creating a new plugin that is a utility object. So again, I would like you to just review the structure of the plugin project. Now that we've talked about the DLL entry, I think it would be helpful for you to look at that. The wizard creates a def file as well, so you can see those things and how they work. Also review your build targets and get in the habit of switching to the hybrid build every time. So that you can do debugging, but you're also working with the release runtime libraries. And then the assignment is to go in and add rollout panel buttons. So the wizard will create for you the default panel, and what you can do is just simply add 2 buttons. So you can use the resource tools to add the buttons. And it's tempting to use the wizard to create MFC handlers. So if you like double click on the button to create an event, like you might do in a managed world, you get the MFC wizard starting up. Do not do that. That gets you into trouble. You can use MFC within 3ds Max, but it's not advised. It's just better to work with the standard Windows APIs. Okay. So what you're going to do is you're going to hook those buttons up to some functions. So you're going to go into the dialog process and look for the resource in the command section and then call your functions. And what we want to do is create a box like I showed in the example and add the box to the scene and apply a transformation. So it's exactly what we talked about right at the end of the presentation. And then as an extra, if you want to go a little bit further, because this is pretty simple stuff, but if you're brand new, it might take you a while to work that out. But if you're familiar with the SDK a little bit already, then what you can do is you can go to this extra step, and I'd like you to add another button to create the cylinder and add the bend modifier attached to the cylinder. Okay, so this creates a parent-child relationship, and it's adding the modifier to the stack that the object owns. And we're going to talk about this more in detail, but it'll kind of give you a preface. It'll also get you thinking about how relationships work. So thanks a lot for your attendance today, and we'll go over this assignment first thing tomorrow. And I hope this is going well for you. Shoot me an email if you're having any trouble viewing it or any problems, and I'll see you at the same time tomorrow. Thank you very much.